Hi guys, so today we're looking at solving equations where x is our index. So by the end of this lesson, you should be able to solve equations where x is the index. For all of these questions, you should have page 21 of your log tables opened, as you will be using your indices rules throughout to simplify your equation. Let's look at an example. This is question 4 on exercise 7.2, part 3. Solve for x, where 10 to the power of x minus 3 is equal to root 10 over 100. Okay, step 1. You must write all terms with a common base. 10 squared is equal to 100. Therefore, 10 to the power of x minus 3 equals root 10 over 10 squared. Step 2. Use your indices rules to simplify your equation. We're going to start off with rule 6. Root 10 can be written as a fraction. That's 10 to the power of a half. This leaves us with 10 to the power of x minus 3 equals 10 to the power of a half divided by 10 squared. So that's our rule 6. A to the power of 1 over q is equal to q root a. So I change my surd into an exponent. I then look at rule 2, where a to the power of p all over a to the power of q is equal to a to the power of p minus q. So I'm going to take my exponents from each other. This leaves me with 10 to the power of x minus 3 equals 10 to the power of a half minus 2. Taking away our values, we get 10 to the power of x minus 3 equals 10 to the power of minus 1.5. Step 3, we equate our indices and solve for x. Equating our indices gives us x minus 3 equals minus 1.5. So we just take all of our indices and we write it as its own equation. And now solve for x. Bringing 3 to the other sides gives us x is equal to minus 1.5 plus 3. And adding together our like terms, we get x is equal to 1.5. Please pause and take down this example. Let's try another question. This is question 4, part 4. 7 to the power of x is equal to 49 over cube root 7. Solve for x. Step 1, write all terms with a common base. So we need to change 49 into an exponent which has a base of 7. 49 is equal to 7 squared. This gives us 7 to the power of x is equal to 7 squared divided by cube root of 7. Step 2. Simplify using your exponent rules. So we now want to simplify this using our exponent rules. Starting off with rule 6, we know that a to the power of 1 over q is equal to q root a. So I can change my root 7 into a third. This gives us 7 to the power of x equals 7 squared divided by 7 to the power of a third. We can continue to simplify this using rule 2. That's a to the power of p divided by a to the power of q equals a to the power of p minus q. When we're dividing two values that have the same base, we can take away their exponents. This leaves me with 7 to the power of x equals 7 squared minus a third. This gives me 7 to the power of x is equal to 1.6. It's equal to 7 to the power of 1.6. In step 3, we equate our indices and solve for x. This gives us x. So just taking your indices, x is equal to 1.6. Please pause and take down this example. Let's try another example. This is question 4, part 6. 8 to the power of 4 over 3 equals 2 to the power of 5x minus 2 over root 2. Step 1. Write all terms with a common base. This means we have to change our 8 into a value which has a base of 2. 8 is equal to 2 to the power of 3. Substituting that into our equation, we get 2 to the power of 3 all to the power of 4 over 3 equals 2 to the power of 5x minus 2 over root 2. From here, we're going to use our exponent rules to simplify. I'm going to start with my left-hand side. Using law 3, I know that a to the power of p equals all to the power of q equals a to the power of p times q. This means that 2 to the power of 3 all to the power of 4 over 3 can be simplified by multiplying our exponents. This gives me 2 to the power of 3 times 4 gives me 12 all over 3. And now looking at my right hand side, I have root 2. So using rule 6, I have a to the power of 1 over q can be written as q root a. So any surd can be written as a fractional exponent. This gives me 2 to the power of 12 over 3 equals 2 to the power of 5x minus 2 over 2 to the power of a half. I can continue to simplify my exponents. So using rule 2, I know that a to the power of p divided by a to the power of q is the same as a to the power of p minus q. So when I have the same base, I can subtract my exponents. This will simplify. And on the left-hand side, 12 over 3 can simplify to 4. This gives me 2 to the power of 4 equals 2 to the power of 5x minus 2 over 2 to the power of a half, which simplifies to 2 to the power of 4 equals 2 to the power of 5x minus 2 minus a half. Now adding together like terms, we get 2 to the power of 4 equals 2 to the power of 5x minus 2 minus a half gives me minus 2.5. In step 3, we're now going to equate our indices and solve for a value of x. So let me just take all of my indices and write it as its own equation. So this gives me 4 to the power of 5x minus 2.5. Solving for x, I'm going to bring my 2.5 to the left-hand side, which gives me 2.5 plus 4 equals 5x. 6.5 equals 5x, and dividing by 5 gives me 1.3 equals x. Please pause and take down this example. Let's try another question. This is question 6, part 1. 3 to the power of 3x minus 1 equals 27 over root 3 all to the power of 5. Solve for x. Step 1. Write all terms with a common base. So we need to change our 27 into an exponent which has a base of 3. 27 equals 3 cubed. Substituting that into our equation, we get 3 to the power of 3x minus 1 equals 3 cubed over root 3 all to the power of 5. Step 2, we're going to simplify using our exponent rules. So the first thing I see here is on my denominator I have a third. So again, going to rule 6, we can see we're using this rule a lot. A to the power of 1 over q equals q root a. So I can change my third into an exponent in fractional form. This gives me 3 to the power of 3x minus 1 equals 3 cubed divided by 3 to the power of a half, all to the power of 5. Continue to simplify. Using rule 2, I know that a to the power of p divided by a to the power of q equals a to the power of p minus q. So remember, you hate fractions, so simplify that first. This gives me 3 to the power of 3x minus 1 equals 3 cubed minus a half, and don't forget that's all to the power of 5. So simplifying that, 3 minus a half gives us 2.5, which leaves us with 3 to the power of 3x minus 1 equals 3 to the power of 2.5, all to the power of 5. Continue to simplify. Using rule 3, a to the power of p, all to the power of q, can be simplified by multiplying our exponents together. This gives us 3 to the power of 3x minus 1 equals 3 to the power of 12.5 times 5 gives us, 2.5 times 5 gives us 12.5. We've now simplified our expression, so the final thing we're going to do is equate our indices. So I'm going to take all of my indices here, and I'm going to solve for x. This gives me 3x minus 1 equals 12.5. To solve for x, I need to move my numbers to the right-hand side of the equation. This gives me 3x equals 12.5 plus 1. 3x equals 13.5. I then want my 3 in its own, so I divide both sides by 3. I'm left with x is equal to 13.5 over 3. X is equal to 4.5. Please pause and take down this example.